Ruben,
Yes, sir.
they just told me my bundle is finished. Joe. That is how come the just went off. But from they are not correct. We just lost John. So let me John. So I hope you understand. You now understand what we are doing. So the common difference,
Yes, sir.
the A is the A is 2. So if you are talking in terms of linear sequence, and D is also 2. So in terms of linear sequence, you are going to get A. You are going to get 2, 4, 6, 8, and so on and so forth. Now in terms of geometric terms, GP. For the GP, the question is saying that the first A plus 2D and the ninth term, which is A plus what they call 8D, are the first 3 terms of the geometric sequence. So looking at this, you can see that the first term is still 2, remains 2, but the second term here will be 6. Oh, I'm wrong. So 2 plus 2 times 2, so it will be 6. Then the third term here will be 18, I guess. So that this will be the first 3 terms of the geometric sequence, geometric progression. I hope you get it. Now,
Yes, sir.
yes. Now, then I want Michelle to join. She's joining, so let us join. Michelle, so this will be the sequence for what they call the linear progression, which is AP, and that of the GP will be this one. That of the GP will be this one. Please, I hope you understand.
Yes, sir.
Yes, sir.
Good. Now the question now says that we should find for what do you call it? We should find for the last question says we should find for the sum of the first 12 term of the exponential sequence. So we are finding for the sum of the first 12 of the exponential sequence. That means the first listen of the GP. But before we can find for that, you have to find for the common ratio. Now the common ratio here is, now that we have our sequence, the common ratio will now become 6 all over 2, which is 3. I hope you agree. Hmm? So
Yes, sir.
the sum of the what they call the first 12 term will be S12 of an exponential sequence or geometric distance. That will be into bracket 2 into bracket. You can see that R is greater than 1. R is greater than 1, so we can use R raised to the power n minus 1. So we can use, I want to write the formula first. So Sn will be equal to what do you call it? A into bracket. In this case, because R is greater than 1, we will use R raised to the power n minus 1 all over R minus 1 minus 1. So in this case, we are going to get S12. Sum of the first 12 numbers go to A, which is 2, into brackets R raised to the power 12 minus 1 all over 3 minus 1. What are you getting, please? What are you getting? So the sum of the first 12. Your answer is 2. Check again. I don't agree. Check again. It's not 2. 3 raised to the power 12. What will you get? That is very huge. 3 raised to the power 12. So there's 2 into bracket 3 raised to the power 12 minus 1 all over 3 minus 1. So check. What do you get? Michelle, what did you get? There's a calculator work. Just use a calculator to do it. Michelle, what do you get?
Said 3 raised to the power 12 minus 1.
So 3 raised to the power 12.
That's 5,
So 3 raised to the power 12 minus 1.
300.
And what are you getting? What are you getting, please?
Said that's the answer.
Yeah, that should give you a certain 5, 3, 4,
5,000. 151,440.
40. Yes, you are correct. You are correct. I hope Ruben, you are now okay.
Perfectly okay.
You said, Ruben, I hope you are okay now.
I'm okay.
Good. Michelle, I hope you are also fine. Okay, now.
Yes, sir.
Good. Now we have something called recurrent sequence. Recurrent sequence. Recurrent sequence. Can I please erase this?
Yes, sir.
Yes, sir.
Okay. Now, with a recurring sequence, you know, a common type of sequence is normally defined by a relation connecting to a consecutive term. So in this case, you realize that you'll be given a relation that connects your consecutive terms. And so it is that relation that the question gives you, you are going to use to solve your questions. You are going to find a U1, U2, and so on and so forth. And so you should be able to understand or discern the relation well. Your failure to be able to discern the relation will definitely help you not to be able to do it. Or it won't aid you, it won't take you anywhere. So you first have to understand the relation. So in this case, you are going to be given a relation, then you are going to use the relation to solve the questions you'll be given. So they can give you a relation like UN plus 1 is equal to maybe 1 plus half UN. So that is it. Then maybe they tell you that, okay, they tell you maybe 2. Then in the same question, they can give you that U2 or U1 is equal to 2. Then they can give you another question to go, hence find this and this and this, maybe find the fifth term or so on and so forth. Now, when you're given a question like this, the first thing you're going to do is you're going to say, okay, the first thing you're going to do when n is equal to 1, you first start from when n is equal to 1. When n is equal to 1, that means anywhere you see n, you put in 1 there. So this means that when n is equal to 1, you're going to get U1 plus 1, which is equal to 1 plus half U1. But however, the question is saying that U1 is equal to 2. So anywhere you see U1, we put 2 there. And so this means that we are going to get a certain, what do you call it? But this will give you U2. This will be U2. U1 subscript plus 1 will be give you 2. Is equal to 1 plus half of U1. Half of U1 is 1. So 1. So you can also say that U2 is the half of U1 is 2 here. So when I put here half times 2, what am I getting? Half times 2, what am I getting? That's 1. So I'm going to also get U2 to be 2. There's something like that. So you are going to be doing something like this, then they can ask you to find for U5. So now you know that the question gave you U1 to be 2 because I just guessed the question. So this may be supposed to be, you are not supposed to get repeating. So maybe since U1 is 2, I was supposed to get maybe U2 to be maybe 3 or 4 or something. And so that is it. But today is how you are going to do it. And so when
Sir,
I give
please repeat the topic.
recurrent sequence, recurrent. Let me spell it for you. Recurrent. It's a little bit dicey, so you are supposed to understand it. So I'm just giving you the clues. Recurrent sequence. Recurrent sequence. Recurrent sequence. There's it. Recurrent sequence. So they give you a relation like this. So this can be your full relation. Then maybe they give you U1 is equal to 2 or U2 is equal to this. So you are supposed to use that they've given you to be able to solve the rest of the question under it. Yes. So that is what you do, eh? I'm coming. I'm coming in. Last me to be some very shit. I think say before. I'm not used to so that is, so they always give you a relation. Then yours is just to understand the relation first. Then through that you can be able to, what do you call it, solve the following questions. So let's try one example and see. A sequence of numbers, U1, a sequence of numbers U1, U2, a sequence of numbers U1, U2. When you be a sequence of SNO, a sequence of numbers U1, U2, U3, and UN. So a sequence of numbers U1, U2, U3 satisfy the relation. So there's a relation I'm giving. Satisfy the relation U n plus 1 plus n2 is equal to n un plus 2 for plus 2 for the integers, n is greater or equal to 1. Is greater than 1 if u1 is equal to 2. If u1 is equal to 2, find I'm going to repeat the question. A sequence of numbers. Ruben, I hope you can hear me. I just lost this thing. I wanted to join. Ruben, can you hear me?
Yes.
Michelle just went this. I wanted to.
Yes, sir.
This one, I don't want to do it. It's a little bit dicey. So I'm coming. So that is it. So if u I is equal to 2, so let me read again. A sequence of numbers u1, u2, u3, dot 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 un satisfy the relation u subscript n plus 1 upper script plus n squared is equal to nun plus 2 for all integers n is greater or equal to 1. Now, if u1 is equal to 2, find a. The values of u2, u3, and u4. Find the values of u2, u3, and u4. So the first thing I'm going to do is to find the values of u2, u3, and u4. Number B, an expression for un in terms of n. An expression for un. An expression for un in terms of n. B will be an expression for un. Michelle, please, I'll repeat the questions. An expression for we have some few minutes. There is no cut, so I want to finish. An expression for un in terms of n. Un in terms of n. In terms of n. So let me just repeat the full question because of Michelle. A sequence of numbers u1, u2, u3 to un satisfy the relation. There's a relation un plus 1, u subscript n plus 1 plus n squared is equal to nun plus 2. For all integers, n is greater than 1 or equal to 1. If u1 is equal to 2, find a, u2, u3, and u4. B, an expression for un in terms of n. Then the last one is the sum of the first n terms, then the value of un plus un minus plus 1 plus this. So far this and that series and sequence is one of the dicey distance, but very simple. So that I told you that when you are giving something like this, the first thing you're going to do is you are going to find them systematically. So you are going to find for u1. So when you are going to find when n is 1, sorry. So you say when n is equal to 1, you are using a relation. So when n is equal to 1, there's a relation you are going to use. So anywhere you see n, you put in 1. So this there'll be 1 here plus 1 plus n squared plus n squared. The n squared here is 1. So 1 squared is equal to 1 times u1 plus 2. Have you seen it? So when n is equal to 1, so that is what I'm going to. You just factor it into the relation your question gave you. So anywhere you see n, you put in 1. So this will give us u2, right? u2 plus 1 is equal to u times, but the question says that u1 is also equal to 2. So anywhere we see u1, we put in this 2. So this is 2. So u times 2 is 2 plus 2. So here will give us 4. So u2 here will be equal to u2 is equal to 4. 4 minus 1. So that will give us 3. Do you agree? Do you understand using the same method, this methodology? Do you understand it now?
Yes, sir.
Michelle, please, do you understand it? Michelle, do you understand it? Now let's do that of the u3. Now the u3, when n, so we are going to start when n is equal to 2. So this is how you do it. So after when n is equal to 1, so you can see that right away the question gave you u1 to be 2. Where is it? u1 to be 2. So u2 here, we can see that u2 is 3 here. Now let's find when n is equal to 2. When n is equal to 2, we are going to get u2 plus 1. We are using the same expression, plus 2 squared is equal to 1 dot u2 plus 2. Now, looking at this, you can see that u2 plus 1 here will give us u3. u2 plus 1, subscript 1, plus 2 squared here is 4, which is also equal to 1 times 2u, or u2. By u2, we found u2 to be 3. So we are going to get 1 times 3 plus 2. And so 1 times 3 plus 2 will give us what? What are you getting, please? So, what do you call it? So, the distance. So, we are going to get where from? I'm coming. Sorry.
So U3 is 1.
I'm coming. So, n is equal to 2. u3 plus 4 is equal to 2. Here, don't forget that here was n, so it wasn't supposed to be 1 here. I was supposed to place 2 here. In this is n, and here the n is 2, so here was supposed to be 2. Are you getting it now?
Yes, sir.
Good. So 2 times u2 here is 6. u2 here is 6. So 2 times u2 will give us 6 plus 8. 6 plus 2. 6 plus 2 is equal to 4 plus u3. So what are you getting u3 to be?
U3 is 4.
So u3 will be equal to 4. So you can right away see that the common difference here is 1, right? The linear sequence is 1. So that is it. So we do for u3. So you realize that now we've been able to also find for u3, making n to be equal to 2. So we are going to also make n, when n is equal to 3, we should be able to find for u4. When the class ends, you join again so that we finish the questions. I will join as under less than 1 minute. I hope you are getting it. Michelle, do you get it? If you don't get it, please let me know so that we go over. I want you to get it.
So I'm okay.
You said?
I'm okay.
Okay. So that is it. When a class ends, you join again so that we finish it. We are just done. So that we finish with everything under series and sequence. Then we know